All right, welcome back to page 2 of our notes for 8.4, which is talking about area of a side angle side triangle or a side side triangle. I know I teased you that we're going to find a segment of a circle. I forgot about one problem in between, so let's talk about problem number 5, where we have a stagehand for production is building a triangular wall, and the triangular wall has side lengths of 80, 120, and 160. So what I am going to do first is say, what kind of triangle do I have here? And the obvious answer is this is a side-side-side triangle. So this is where Heron's formula is going to kick in. So first thing that we are going to do is we are going to find half the perimeter. So half the perimeter is going to be 1/2 of 80 plus 120 plus 160. So 1/2 of 80 plus 120 is 200. 200 plus 160 is 360. 1/2 of 360 gives me 180. We should know that with all the work we've been doing in circles. So the half the perimeter is 180. And now Heron's formula says our area is going to be the square root of 180 times 180 minus 80 times 180 minus 120 times 180 minus 160. So that would be the square root of 180 times 100 times 60 times 20. Let's clear everything out here for just a moment, Doc B. So let's go ahead and find the square root of 180 times 100 times 60 times 20. Let's put a decimal point in, and we get our area of this wall is 4,647.58. Let's add another decimal onto that, or in this case, 2 decimals, 00. It'll be 0.5800. All right. So this is how much square feet the wall is. So square feet, or how many square feet, pardon my English. So for part B, if each gallon of paint covers 450 square feet and the paint is sold for, we have some certain prices for our paint, how much would the stagehand have to spend, including tax, to cover the wall? So we've got a real life application of math. Yay, I love this. So first thing I'm going to do is say how many gallons, so number of gallons that I need. So to find the number of gallons, we are going to take that 4647.580. We're going to figure out how many square feet we have, and we are going to divide it by 450, and that would be square feet per gallon. If we do dimensional analysis, this will give us the number of gallons. So I'm going to take that number of square feet, divided by 450, and we get 10.328. Now, I don't know how many of you have ever tried to buy 0.328 of a gallon. Not possible. Paint is usually sold in either quarts, and therefore quarts in a gallon. So we have more than 0.25, or they're sold in actual gallon buckets or 5-gallon buckets. So in the end, what I need is I am going to need 11 gallons of paint. So to get the 11 gallons of paint, I'm going to break it up into 2 5-gallons plus 1 gallon. That way we can minimize the amount of cost. So if we take 2 times the 139.99 and we add it to the 32.99, let's go ahead and throw that into the calculator. So 2 times 139.99 plus 32.99, that gives us 312.97, so $312.97. And then we cannot forget to multiply this by 1.07 because we have to add the sales tax. So take that answer times 1.07, and we are going to end up spending $334.88. So that's an expensive wall. That's okay. It's for production, so it's worthy. Problem number 6, we are going to find the area of a sector of a circle, and this sector of the circle has a radius of 6 inches. This is great because it brings back stuff that we did way back in 6.1. I don't know if you guys remember, the area of a sector is 1/2 theta times r squared, where that theta has to be in radians. So the central angle of this sector, and by the way, we are finding this entire area right here. So that area is going to be 1/2 theta in radians would be 85 degrees times pi over 180 if we do our conversion, and then times the radius squared, so times 6 squared. Let's go ahead and throw this into the calculator. 0.5 times parentheses 85 times pi divided by 180. Close off our parentheses and then multiply that by 6 squared, which is 36. And I get the area of this sector is 26.7035 square units. Now, the second part is find the area of the segment. And what is a segment? If you notice by this drawing, the segment is going to be the entire length or the entire area of the sector, but then we are going to subtract out the area of the triangle that gets formed here. So this is our area of our sector. What we are going to do is now we are going to subtract out the area of the triangle, and we are going to be left with what we call the segment of the circle. Now, what kind of triangle do we have here? We have, we know both radii are going to be 6, and we know the central angle is 85 degrees. So let's subtract out 1/2 a times b. Let's go ahead and write that as 6 times 6 times the sine of 85 degrees. So I'm going to put that in 0.5 times 36 times the sine of 85 degrees. Now I'm in degree mode, so it doesn't matter if I have this in radians or degrees. So I will be subtracting out 17.9315. So the area of the segment is going to equal the area of the sector minus the area of the triangle. So geometrically, the area of the segment, which would be this portion, is going to equal the area of the sector, which would be the whole ice cream cone, subtract out the area of the triangle. So let's throw that into the calculator. The area of the sector, subtract out the area of the segment, or the triangle, and our area of our segment is 8.772 square units. So segments are kind of useful. There's a problem in our homework that's going to involve like using a segment of the circle, cutting that out so that it can find the, or like so it can wrap it around and form a teepee. Interesting way of doing it. But I'm going to go ahead and end this video so I can introduce one of my favorite problems of all time, which is called the cow problem.